AI is turning silver into a power metal, and the first signal will not be the spot chart. The first signal will be the same place every real commodity squeeze begins: in the plumbing, in the boring parts of the system that decide whether electricity can move, whether hardware can ship, whether a factory line stays alive, whether a deadline gets met, because the AI boom is not just a chip story. It is a load story, a power story, a grid story. And when the world starts racing to build more compute, the race quietly becomes a race to secure the materials that make high current systems reliable. Silver lives inside that reliability, not as a fantasy where every server is stuffed with, as a thin, critical presence in contacts, connectors, switching, and the electrical nervous system that makes modern infrastructure behave. So if you came here because you want a clean answer to one question, is AI bullish for silver, you are going to get something better. You are going to get a map of where silver actually sits in the AI power stack, what a real demand shock would look like. And the 3 dials that tell you whether this story is becoming physical before the internet turns it into noise. If you value calm investigation more than hype, subscribe. This channel is built for long-form mechanism, not slogans. And share this with a friend who thinks silver demand only comes from the usual stories, because the next chapter in silver might not look like a silver story at all. It might look like a power shortage story. Now let me open with a scene that will make the entire episode click. Walk into a data center corridor. The air is colder than you expect. The sound is constant, a low roar that never stops. There are lights that blink like a city at night, rows of cabinets, each one an apartment building for computation. But the real drama is not in the cabinets. The real drama is upstream. Follow the cables, the bus bars, the breakers, the switchgear, the transformers, the substation connection. Follow the power delivery path that turns a promise of electricity into real current, flowing, stable, controlled. Because AI is not limited by imagination. It is limited by electricity, and electricity is not limited by software. It is limited by hardware, grid approvals, lead times, and the ability to scale high reliability power infrastructure without breaking. This is where silver enters the story in a way most people never consider. Silver is not the headline. Silver is the contact, the tiny interface that decides whether current flows cleanly or arcs, whether heat builds or dissipates, whether a switch cycles for years or fails early, whether a system stays stable under load spikes or becomes fragile. In normal times, that is background. In an AI build-out, that background becomes a bottleneck. So here is the first truth you need to hold tightly. A commodity does not need a huge new use to get repriced. It needs a new kind of buyer, a buyer who cannot easily substitute, a buyer who must meet deadlines, a buyer who will pay for certainty. That kind of buyer changes the price of immediacy, and the price of immediacy is where silver reveals its real power. Now, let us define the AI load shock without drowning in jargon. When people say AI is changing the world, they often talk about intelligence, models, and chips. That is the visible layer. The less visible layer is that training and running large. AI systems demands dense computation, and dense computation demands electricity, not as a one-time burst, but as sustained load. And sustained load at scale forces a redesign of power delivery. You do not just add servers, you add transformers, you add switchgear, you add distribution upgrades, you add transmission connections, you add backup systems, you add cooling, which adds more power demand, you add redundancy because downtime is unacceptable. So the demand is not only bigger, it is more demanding. It stresses a grid in a specific way. It pulls power in concentrated locations. It forces interconnection queues. It drives expensive upgrades. It creates lead time pressure in equipment that was already slow to manufacture. This is why, in many regions, the first constraint on AI is not chip supply. It is the ability to deliver power on schedule. So here is the question that matters for silver. Where does silver sit in the power build-out stack? It sits in places that have a shared theme: high reliability, electrical interfaces, switching contacts, connectors, control components, electronics that manage power, systems that must operate with low losses, high endurance, and consistent performance. Now, be careful. This is where the internet ruins the story. The internet wants a number per server. It wants ounces per rack. It wants a simple multiplication that ends in a dramatic conclusion. That is not the right way to think about this. Because the real mechanism is not acute ounces per device story. The mechanism is procurement behavior under infrastructure deadlines. When a region is trying to add massive electrical capacity fast, the buyers stop shopping for price and start shopping for delivery. They sign long-term agreements. They qualify suppliers. They pre-order. They build buffers. They pay premiums for lead time certainty. That behavior can tighten supply chains even if the metal content per unit is small. Small content times massive deployment plus urgent procurement equals a sticky bid. That is the heart of the episode. Now let us make this tangible with a simple image. Imagine a breaker, a piece of equipment that most people never think about unless it fails. The breaker exists to do something dangerous safely, to open and close circuits under load, again and again, without turning your infrastructure into a fire risk. A breaker's performance is not a vibe. It is physics. Contacts must carry current. Contacts must resist wear. Contacts must manage heat. Contacts must avoid failure modes. And those contacts often use materials chosen for conductivity and reliability. This is why silver shows up in electrical applications so consistently across modern systems. It is not because anyone wants to gift money to silver suppliers. It is because reliability is expensive and failure is more expensive. Now take that one breaker and multiply it across a data center build-out. Then multiply the data center build-out across many regions. Then multiply the regions across the global AI race. Now you can see why a small per unit story can still matter, not because silver becomes a bulk ingredient like steel in a bridge, but because silver becomes a strategic interface material in the parts of the system that cannot fail. Now we need to confront the second truth that makes this story powerful. The grid build-out matters more than the servers. Servers are high visibility. People take photos of racks. People talk about chips. People argue about which model is winning. But servers sit downstream of a much larger infrastructure footprint. Power, generation, additions, transmission, substations, distribution, switchgear, transformers, interconnection, and these are not fast industries. These industries have long lead times, permitting friction and equipment constraints. So when AI accelerates data center demand, it forces a broader electrical build-out. That is where the most supply chain stress occurs. And supply chain stress is where commodities Now let me give you the most important ledger beat in this episode. You think you bought silver at spot, but industry buys silver at the price of Industry buys it through components with lead times, through qualified suppliers, through contracts, through penalties for delays, through the real cost of missing an infrastructure deadline. When lead times become the enemy, buyers will pay more to avoid being late. That is when the market shifts from price sensitive to schedule sensitive. Schedule sensitive demand is stickier. That is the kind of demand that can create a premium. Now, to stay honest, we must say something that keeps you from being manipulated by this story. AI does not need to consume huge amounts of silver to matter. If you find yourself craving huge numbers, you are already in the danger zone where hype grows. What matters is whether the AI build-out adds incremental industrial demand that is inelastic and concentrated in time, while the supply chain for specific silver-bearing components is not infinitely scalable. Because bottlenecks are not global. They are specific. A market can have plenty of silver in the abstract and still have a shortage of the specific form needed for a specific industrial process. That is where the price of immediacy rises. So now we build the core map of the AI power stack in plain language with no fantasy. There is the compute layer, servers, boards, connectors, power supplies, internal distribution. Silver shows up in places where electrical connection quality matters. There is the facility layer, power distribution inside the building, switching, monitoring, protection systems, redundancy. Silver shows up in the interfaces, the contact points, the components designed to cycle and endure. There is the grid connection layer, transformers, switchgear, substation equipment, high current control gear, protective systems. Silver shows up again in reliability-driven components that manage and interrupt current. There is the expansion layer, new lines, upgrades, additional capacity, more redundancy, more equipment orders. This layer is where lead times can stretch, and lead times are where procurement behavior changes. Notice what we are doing. We are not claiming silver is the dominant material in every piece of hardware. We are claiming silver is repeatedly used in critical interfaces across an expanding electrical footprint, and that the footprint is being forced to expand faster than the system is comfortable with. That is a plausible mechanism for incremental demand pressure. Now, how does incremental pressure become a market event? It becomes a market event when it creates recurring tightness in the price of immediacy. In other words, when buyers begin paying up to secure delivery, and those behaviors persist. So here is the third truth you must internalize. Commodity markets rarely reprice because of one giant buyer. They reprice because many buyers behave differently at the same time. They move from just-in-time to just-in-case. They move from spot to contract. They move from optional to essential. They move from price shopping to supplier locking. That is the kind of shift that tightens free supply. Free supply is a supply that used to float around without being committed. When free supply shrinks, the market becomes sensitive. When the market becomes sensitive, small shocks create big moves. And the AI build-out is the kind of structural pressure that can make many buyers behave differently at once. Now, we have to address the big confusion that always shows up in comments. People will say, but silver is used everywhere, so how can it suddenly matter? And the answer is simple, because markets do not care that a metal is used everywhere. Markets care about incremental change at the margin If a system is balanced, it takes a small incremental demand shift to change pricing power. If a system has bottlenecks, it takes an even smaller shift to create dislocations, and dislocations are the earliest warning sign. Dislocations are when one part of the market starts paying a different price than another part, and the gap does not close quickly. That is the sound of friction. Now we are going to build the viewer's mental defense against the most common trap. The trap is confusing a narrative with a timeline. The AI build-out can be real and still be delayed. Grid upgrades are slow. Interconnection queues are real. Permitting can delay projects. Economics can slow deployment. So you cannot treat this as an instant demand shock. You treat it as a pressure campaign on the supply chain. Pressure campaigns create waves. One region surges, then another. One set of equipment, lead times, stretches, then stretches again. One batch of projects hits the same deadline window. Procurement panic appears, then phages. This is how the story will likely look if it is real. Not a single straight line, a pattern of tightening episodes. Now we build a counter case early because it will keep the episode honest. The counter case says forecasts can overshoot. Data center growth can slow or shift to different regions. Efficiency improvements can reduce power demand per compute unit. Hardware design can optimize material usage. Substitution exists in many electrical applications. Supply chains adapt, recycling increases, and even if AI accelerates power build-out, silver intensity per unit might fall enough that the incremental silver bid is smaller than enthusiasts claim. That counter case is real. So the only responsible approach is a diagnostic approach. We watch the dials. We do not worship the story, and we do not dismiss it either. Now, before we move into the diagnostics, do me a quick favor. If you are still here, you are not watching for entertainment. You are watching to get smarter. Subscribe so you do not miss the next episode in this silver series, because the episodes connect like a map. And share this with one friend who keeps asking why silver behaves like it does. Because once you understand the plumbing, you stop being shocked by the chart. Now, here are the 3 dials that will tell you whether the AI power story is becoming a real silver story. Dial 1 is power demand reality, not memes reality. Do grid operators, utilities, and planners keep revising expected load upward? Do regions start talking about capacity stress? Do interconnection backlogs become the headline? Do capacity, prices, and upgrade costs climb? When those signals intensify, the power build-out pressure is real. Dial 2 is procurement behavior. This is the one most investors never watch. Do equipment lead time stretch? Do buyers sign long-term contracts? Do suppliers ration? Do terms tighten? Do you hear secure supply language from the electrical infrastructure ecosystem? This is where inelastic demand becomes visible. Dial 3 is the price of immediacy in the relevant industrial channels, not the spot chart. The price of premiums, lead times, and persistent tightness signals in the inputs and components that require silver for reliability. If those persist, you are watching a structural bid, not a passing narrative. Now we are ready to go deeper, because the heart of the story is not just that AI uses power. The heart of the story is how stress transmits through the electrical supply chain, how bottlenecks form, and how a small material embedded across many critical interfaces can become strategically valuable even when the world thinks it is just another metal. And once you see the transmission chain, you will understand why the AI boom can reprice silver without anyone needing to invent a conspiracy. And without silver needing to become the dominant ingredient in anything, it only needs to become schedule critical. It only needs to become schedule critical because the moment something becomes schedule critical, it stops behaving like a normal input and starts behaving like a constraint. And constraints do something to markets that most people misunderstand. They do not always raise the spot price first. They raise the price of certainty first. They raise the cost of getting the right thing on time from a trusted supplier without surprises. That is the world the AI boom is pushing us toward. A world where power infrastructure is being ordered under urgency, where lead times matter, where interconnection queues become political, where every delay has a cost that is measured in millions, sometimes billions. And in that world, the materials that live inside reliability are not optional. They are not purchased like a commodity. They are secured like an insurance policy. Now let us walk through the transmission chain, because this is the part that turns the idea into a real mechanism. First, demand for compute rises. Not just any compute, fancy compute, always on compute. Compute that runs hot, runs hard, and runs nonstop. Second, dense compute turns into dense electricity demand. A data center is not a warehouse. It is a machine that turns electricity into results. And the more results you want, the more electricity you must push through the system. Third, dense electricity demand turns into local grid stress. Not because electricity is rare in the abstract, but because electricity must arrive in specific places through infrastructure that was not built for sudden concentrated load. Fourth, local grid stress turns into equipment orders. Transformers, switchgear, breakers, control gear, bus bars, power distribution upgrades, protection systems, redundancy systems. Fifth, equipment orders turn into lead time pressure. Because these are not items you click and buy, these are manufactured systems with constrained capacity, specialized labor, and qualification requirements. Sixth, lead time pressure turns into procurement behavior, long contracts, supplier locking, buffers, priority queues, paying for delivery, paying for certainty. Seventh, procurement behavior turns into tightening in specific component supply chains, not the entire world at once. Specific nodes, specific grades, specific parts that cannot be swapped without redesign and finally, that tightening transmits upward into the broader silver story, because silver is embedded in the interfaces where reliability matters most. Now I want you to feel why this matters. If you are a data center operator, the worst outcome is not paying more for a component. The worst outcome is being late. Being late means you are not generating revenue. Being late means you are losing share. Being late means your customer goes somewhere else. Being late means your financing model breaks. So when the system is under time pressure, buyers stop optimizing for the lowest unit cost. They start optimizing for throughput and reliability. They start paying the premium that makes suppliers say yes. That is how a boom turns into a squeeze. Not because the world ran out of metal, but because the world ran out of time. Now let us place silver inside that reality in a way that does not rely on fantasy numbers. Silver matters in electrical systems because it is an exceptional conductor and it performs reliably in contact applications. Contacts are not decorative. Contacts are where electricity meets the surface and must pass through without turning into heat, noise, failure, or arcing. Over time, those tiny interfaces determine whether a system is stable or fragile. In an AI build-out, stability becomes everything. A power system that fails does not just cause inconvenience. It can shut down racks, crash workloads, damage hardware, violate service agreements, and wipe out trust. So the industry pays for reliability, and reliability often means specific materials, specific processes, specific suppliers. This is why the silver story here is not about a single device. It is about a growing electrical footprint that repeats the same kind of reliability components again and again, at scale, under urgency. Now we need to address the thing your viewer will ask immediately, because they always do. If this is Hayao, why has the silver chart not already told the story? Because charts react to attention, and attention arrives late. The physical world moves through contracts, lead times, and procurement cycles. By the time the spot chart looks dramatic, the procurement decisions were made months earlier, the equipment was ordered earlier, the supply chain got tight earlier. The first people to notice were not traders. They were buyers who started hearing the same sentence from suppliers again and again. Lead time extended, minimum order increased, terms tightened. Allocation began. Those are not headlines. Those are whispers, and markets ignore whispers until they become screams. This is why the first signals of a real AI-driven tightening will not look like an announcement. They will look like friction. Friction in delivery, friction in sourcing, friction in lead times, friction in the cost of certainty. Now let us steel man the counter case, because it is the only way to keep this episode honest. The counter case says AI demand projections can overshoot. It says efficiency gains can reduce power per unit of compute. It says data centers can shift locations, spread out, or delay builds. It says grid constraints can slow the pace of deployment. It says regulators can cap growth in certain regions. It says the build out will happen, but not as fast as the most aggressive narrative claims. It also says silver intensity can be optimized down. Engineers can reduce precious metal usage in many applications, substitute where appropriate, redesign contacts, and improve material science. Supply chains adapt. Recycling improves. Manufacturers expand capacity. In the counter case, AI is real. Power demand rises. But silver does not become meaningfully tighter because the system adjusts. That is a rational counter case. And it is why we do not treat this as a prophecy. We treat it as a testable mechanism. So here is the falsifier. If power infrastructure build-out accelerates, and yet you do not see persistent procurement footprints, no persistent tight, irrelevant component lead times, no persistent premium behavior in the silver inputs used by those industries, then the AI silver squeeze story is mostly narrative. If those footprints appear and persist, then it is becoming real. Now we move from theory to the 3 dials again, but this time we go deeper, because you need to know what each dial looks like in real life. Dial 1 is the power demand dial. You watch where the grid operators and utilities keep warning about load growth that is faster than planning cycles were built for. You watch whether capacity stress shows up as rising costs, tougher interconnection terms, and a growing sense that electricity is not just a commodity but a bottleneck. When this dial is rising, it does not mean silver must spike. It means the pressure campaign on the electrical supply chain is intensifying. Dial 2 is the procurement dial. This is the most important dial because it tells you whether buyers are acting like this is urgent. Urgent procurement has a smell. It looks like long-term supply agreements. It looks like suppliers setting tougher terms. It looks like buyers accepting those terms because the alternative is delay. It looks like delivery windows widening. It looks like prioritization. It looks like allocation. It looks like everyone's trying to secure the same categories of equipment at the same time. When this dial rises, the system is shifting from price sensitive to schedule sensitive. That is when tightness becomes sticky. Dial 3 is the immediacy dial. This is where silver becomes visible without needing a dramatic spot move. When a real industrial bid tightens a market, the first place it tends to show up is in the price of getting the thing now, not later. Now, it shows up in stubborn premiums and delivery tightness in the industrial channels that depend on reliable silver-bearing inputs. It shows up as friction that does not immediately resolve, even when the chart calms down. If the immediacy dial is rising while the power demand dial and procurement dial are rising, you are not watching a meme. You are watching a supply chain reprice itself for urgency. Now let us talk about why this creates volatility, because that is what your viewer will experience. Silver is a market that amplifies. When industrial tightness appears, it attracts narrative. Narrative attracts speculative flows. Speculative flows attract leverage. Leverage increases volatility. Volatility triggers risk tightening. Risk tightening forces weak hands out. So even if the underlying story is real, the path will not be smooth. You can see a market become physically tighter and still see the paper price whip violently. That is not a contradiction. It is silver's personality. This is why the correct mindset is not to expect a straight line. The correct mindset is to recognize that a new demand driver that is sticky can change the floor of industrial interest, even while the market remains emotionally violent in the short run. Now, here is the key synthesis, and it is worth repeating until it feels obvious. AI does not need to consume massive silver to matter. It only needs to accelerate the build-out of high-reliability electrical infrastructure, and that infrastructure only needs to tighten procurement behavior enough that the price of certainty rises. When the price of certainty rises, the market pays. And when the market pays, silver starts behaving less like a simple chart and more like a constrained system. So if you are watching silver and you want to know whether this story is real, do not look for a headline that says AI is buying silver. You will not get that. Look for the quiet evidence. Look for the world paying more to get power equipment delivered on time. Look for lead times stretching in the electrical supply chain. Look for procurement language shifting from cost to security. Look for the price of immediacy becoming stubborn. Those are the tells. Now, if you have stayed with me to this point, you are exactly the kind of viewer this channel is built for. Subscribe, because the next episodes in this series connect together into a full map of silver's real drivers. And share this with a friend who keeps treating silver like it moves for one reason at a time. Because silver is a system, and systems move when constraints appear. Here is the closing truth. The AI boom is rewriting the power grid's priorities. The power grid's priorities are rewriting procurement behavior, and procurement behavior is what turns a metal from background into strategic. Silver will not be repriced because of a viral number. It will be repriced because the world decides it cannot afford to be late. And when the system cannot afford to be late, it starts paying for reliability. Silver lives inside reliability.